All right. We're going to start on our third lesson in this unit, okay, which is on quadratic applications. And the biggest emphasis that I want to talk about is actually, what is that? Vertex form. The good thing about doing this lesson after the last lesson is whether or not you realized it, when you're talking about the number on the inside and you're talking about the number on the outside, you are actually locating the vertex of this quadratic formula. Let me fix my microphone. All right. I do want to make a connection, though. All right. When we were in the last unit, you worked with equations like this. For example, x squared minus 8x, let's say plus 12. Do you remember working with anything like that? You don't. Okay. What if we said equals 0, and then we said, okay, let's do parentheses. You remember that? Okay. This is a trinomial, right? And when we did the quadratic formula, we actually talked about the a value being, what would the a be? Would be the number in front of x squared, which would be 1. What would the b value be? Negative 8. What would the c value be? 12. Now, in this unit, we're not actually going to solve. We solved everything we could possibly solve, all the different ways that we needed to solve them in the last part. Now we're going to say y equals, and now we're going to start connecting to graphs. I would hand draw these for a long time. Do y'all remember when we'd solve, we'd get 2 answers? Miss Jessup say, okay, it crosses at such and such and such and such. Those are my answers. But I never made you get your calculator out, and we never actually did that side of it. I did that several times, and some people would say, do we have to draw that every time when we do it? Y'all remember that? Okay. What I need you to know is this actually is called the standard form of the quadratic. This is the standard form. You could easily type this in your calculator, and I'm going to. All right, I'm going to graph this, and when I put this on y1 equals, I'm actually going to type in x squared. Here's the shortcut key for x squared minus 8x plus 12. All right, and when I press graph, there comes the parabola. Everybody knows that it makes that U shape, right? This entire big unit, unit 3 is quadratics. I did split it into section A, which was the solving, and now we've got to do the application stuff, which is in part B. I need you to learn to connect it to the graph. That is the graph of this equation. Everybody good? Now, on many times we would say, you know what, we need to solve this, and this one would solve by, starts with letter F. Factoring. So how could I factor? And we said, okay, we could use the x puzzle. We ask ourselves what multiplies to give 12. It's going to add to be negative 8. And it is 6 and 2. What kind of 6 and 2? Negative and negative. Negative and negative. Okay, so it'd be minus 6 and what? Minus 2. Now, I'm not solving it, but if we did, we could solve it, correct? All right. If we did solve it, I guess let's talk about that. What would my 2 answers be? 6. We'd say x minus 6 equals 0. So the first answer would be positive 6, and the second answer would be positive 2. So I have 2 answers, positive 6 and positive 2. Now, if this is called standard form, what do you think the second version is called? Nope, starts with letter F. Factored form. Everybody good? Okay. Now, is that the same equation? Are these two basically the same equation? No? You don't believe me? Oh, imagine that. What if I put the second equation in y2, and it was x minus 6, close it, and parentheses x minus 2, and close it. All right, here we go. Here's the second one, and boom, it's there. Did you see it? Where is it? They're the same thing. Are you getting what I'm saying? Do you agree that this version of the equation and this different version of the equation are basically the same one? Yes. Guys, the state seems to think you guys need to know not just 1, not even 2, but guess what? 3. And today, we're going to learn how to find the third version. Technically, you have been working with the third version, you just didn't know what it was. All right? So in a way, today is not going to be super hard. It's just going to be about pulling some information you've done previously and pulling it together. All right. Guess what the third version is? Vertex form. We have standard form, which is everything multiplied out in descending order. Then we had factored form, which usually has parentheses. And then we're going to talk about, I'll tell you this one. See if I change that, it should be parentheses squared. I think it's got x minus 4 and minus 4. Do you recognize that version of the equation? Yes. Did you do anything that had inside numbers and outside numbers yesterday and the day before that? So you've been working with the written version of this equation. You just didn't say, oh, we're doing the vertex form. But we are. This inside number means it moves what? Left and right, but opposite. What's opposite of minus 4? Plus 4, which means it's actually going to go right 4 units. Okay, what about the number on the outside? That's going to make it go down 4. If I did my mental math correctly, this version of the equation, which is actually called the what? Vertex form, because if I look at the numbers right, I can actually pull down the vertex. This version, and this version should all be what? They should all be the same exact thing. So if I come down to y3 and I type in x minus 4, close parentheses, squared minus 4, and graph. And here it comes. Boom, there it is. Did y'all see it? So we have 3 versions of the same equation. Does everybody see what we're talking about? This is called what again? What's this called? Standard form. What's this one called? And what's this one called? Vertex form. Standard form, vertex form. Okay. Now let's go to your paper. Okay. Everybody got the sheet? Okay. Let's just see. You have a picture on the paper. The vertex is the turning point. It's the lowest point or the highest point depending on the graph. What is the vertex? Well, the vertex would be way down here. Go ahead and put a dot on that. Put your dot down there. Now let's plot the point and see what it is. How would I get to that point right there? You go over 3 and then what? Down 7. Over 3 and what? Down 7 would be negative 7. Does everybody see that the vertex is at what? 3 and negative 7. Okay, let's take a look at the equation. Let's just pretend, is there any way we might have could have guessed that's where it was at if we didn't have the picture? Okay, let's take a look. Here's my inside number. My inside number is negative 3, but the negative number always goes in what? Inside goes in as opposite. So what's opposite of negative 3? Positive 3. And what about the outside number? Same. Do you see how that works together? Those two numbers that told you how much it shifts left and right and how much it shifts up and down, that located the new start point. And when I had you get whiteboards and I was saying, put that 1 dot on there. Remember when we said put that 1 dot on there? You were always doing the vertex. You might not have realized it, but you were doing the vertex all along. Let's do the next one. Find the lowest point on the graph. What would be the coordinates of the vertex of that graph? Negative 4 and down negative 5. Does that agree with what you would assume it would be from the equation? Inside comes out what? Opposite. And the outside comes down what? Same. Last one. It's not my lowest point. This time my vertex is going to be what? The highest point. It's always where it turns. And this one only turns 1 time. Every quadratic turns 1 time. It either comes up, turns, and goes back down, or it comes down, turns, and goes back up. They only have 1 turning point. And that was it. So what's this one? Over 5, up 9. Does that agree with what you thought? Inside comes down as opposite, and this one comes down as what? Same. Are you seeing a connection with what we're talking about today and what you just did the last 2 or 3 days? Actually, that's 2.5 days for sure. Okay, is it kind of making connections for you? And that's what I have to do. I have to connect what we talked about in the last part of Unit 3 with this next part of Unit 3. All right, let's go to the bottom of the sheet. I copied notes so that if perhaps you want to go back and read an example word for word, they're explaining it word for word. Here's what I need you to know, because I'm getting ready to walk you through 3 examples, and I think after we walk through 3, you'll be fine. The phrase that I need you to know, and write it down if you don't remember it. Ready? Half it, then what? Then square it. Because we are doing what's called completing the square. Jump back. Have we ever done that before? Yes. We learned to complete the square as a method to solve. Okay? We learned to complete the square as a method to solve. We're not solving today. We're just trying to move one version of the equation into another one. Okay. Oops, don't need to see those. Boom, magic, they're gone. Okay. Let's do the very first one. When you try to find the number to half, it's always the number in front of x. Okay? So find the b value in front of x. Find the b value. Find the b value in front of x. That's the one you're going to half it and square it. Are we good? All right. What is half of 4? 2. What's 2 squared, which is 2 times 2? 4. Everybody good with 4? Let me say that one more time. What's half of 4? 2. What's 2 times 2? 4. So I need an extra 4. And if I just come in here and I add the extra 4, well, I can add anything I want to. Or can I? Can I just jump in here and say, you know what, I need to add 4? Is that okay? Is everybody saying no, it's really not okay? Okay. All right. Is it okay if I walk in here and said, you know what, guys, I won the lottery last night. I am now a millionaire, and I really, really, really like a Santa. Santa, you're my favorite student in 4th period. I want to give you $1,000. Isn't that fair? Is that fair of me to give her $1,000 and just leave the rest of you guys out? No, it's not unfair. Well, you're right. It would be my choice, but you wouldn't like that, would you? It is not fair to just throw in a 4 and leave it, because we changed the equation. But I can do this. I can say, you know what, if I add a 4 here, I'm going to come out behind it and say subtract 4. Is that okay? Hey, I'm going to add 4 to you, then I'm going to come over here and I'm going to take 4 away from him. But in the whole class, is that okay? Well, I took 4 from you and gave to him, so now the money that was in the room is still in the room. It's the same problem as it was before, guys. Okay? I can add. Now, when we were solving, do you remember how when we were solving, I had an equals, and I had like equals 12, and maybe if I did like x squared plus 6x, I would say what? Don't write this down. Don't write this down. What's half of 6? And 3 squared is? So I'd add 9. And if I added 9 to one side, I had to what? Add 9 to the other side. I was solving then. I'm not solving now. I'm only working with what? One side of the equation. So that's why if you add it in one spot, you're going to end up what? Subtracting it somewhere else. Now, here's what I want you to do. Draw a box for me around the first 3 parts. Leave out the minus 4. Put a box around the first 4 parts. We only have about 5 more minutes and I'll be done. This part is now a perfect square trinomial. It factors perfectly into 2 sets of parentheses. What multiplies to give 4 that adds to be 4? 2. 2 times 2, right? So x and x plus 2 and plus 2. Everybody good with that? Okay. Plus 2 and plus 2. Is there another way you can write that if there are 2 things are exactly the same? X plus 2 what? Squared. Remember that minus 4 that we left dangling out there at the end that we haven't talked about yet? Got to bring it down. Do you now have your inside number, and did that minus 4 at the end become your outside number? Y'all see it? It does seem long right now, but it's really not. Okay. What would my vertex be? Inside comes out what? Opposite. So it'd be -2, and the outside comes out same as. My vertex should be -2 and -4. Guys, I took a long time to talk you through that. The other class thought it was really long. Why do we have to learn this? That seems too hard. And by the end of the period, they were just rolling with it, and you will too. It's just like when we started these around the world things. The first few were really tough, and then you got to going better and better with it. I'm going to jump straight to number 2. Okay, this time I actually have an 11. Everybody see that? So my function I'm working with, this is actually in what? Right now it's in what? It's in standard form. I don't want to change the equation. If I type it in y equals, I want it to have one graph. I just want to change it to vertex form where I can see the vertex really fast. Are you ready? Keep the x squared, keep the 6x. 11 is probably not the number I need. Matter of fact, what is the number I need? Half of 6 is 3. 3 squared is, I need a 9. I don't need an 11. So I'm going to pull the 11 away. So leave some space and pull 11 away. Now in the middle of the problem, I'm going to add the 9 that you just told me I needed. And if I add the 9 here, at the end, I'm going to come out and take the 9 back away. So I'm basically adding 9 in one part of the equation, but I am subtracting 9 in another side of the equation. What if you add 9 and subtract 9? What do these two add up to be? 0. Can you add 0 to anything? I can add 0 all day long. Does it change it? No. Does everybody see what I'm doing? Miss Jessup is not changing the equation. She is changing the appearance of the equation. Is everybody good? Okay. I'm going to put a box around the first 3 parts because I have now created a perfect square trinomial. It should factor perfectly into 2 sets of parentheses. Anybody know what it's going to be? Positive or negative? Positive, positive. Did anybody remember that it's always the half number, including the sign? Okay, and that becomes x what? X plus 3 squared. And this time, I am going to have to pull down, but I'm going to have to combine these two. So what happens if you say plus 11 minus 9 plus 2? I have now changed it from standard form to vertex form by completing the square. That was in the last unit when we completed the square. We were solving. Yeah, it is the same thing. All right, what's my vertex? -3 and +2. Last one, okay? First 2 parts is what I look at. Middle number is what? -10. What's half of -10? -5. What's a -5 times -5 twice? +25. When you square it, even if you square a negative, you always get what? Positive. So I need a 25. I don't need a 2. So x squared minus 10x. Pull the plus 2 away. In the middle of the problem, what am I going to do? Add the 25 I need. What am I going to do at the very end of the problem? Take away the 25 I just added. Everybody good with what we just did? I have a perfect square trinomial in the first 3 parts because I made it. You made it be a perfect square, right? Ooh, that hurt. Why do I do stuff? Trying to make it. It's kind of sort of. What goes in my parentheses? -5 and -5, -5, -5 is -10. What about on the outside? -23. So my final answer is x minus 5 parentheses squared minus 23. What does my vertex turn out to be? +5 and -23. This one comes down as opposite, and the second one comes down as same. Okay? And that is my vertex. Now, any questions? Let me ask you something one more time. Why did I plus 4 and subtract 4? Because I halved it and squared it and got 4. And if you add what you need, you have to what? Go to the end and subtract it back away.